So my name is Cheuk, and so this talk is about why AI industry would need a revision control graph database. So there's two things here. There's like revision control, which I guess some of you may already know what that means. Like you may be familiar with other revision control tool like Git. And there's another thing, graph databases. So I think it's like I have like a new word here about graph databases, but I would like to introduce you this concept of like modeling your data in a graph format rather than what we traditionally do in relational database. There are tables. There's like we love SQLs, right? So yeah, what are the alternatives? So also the slides it's online, it's available, it's on my slide deck there that you could find the link. Also my contact detail. I'm happy to chat with people who have questions. Maybe you suddenly wake up one day, like a few days later, that, oh, I have a question, but I forgot to ask Cheuk. You can find me on Twitter, I guess. So let's get started. So yeah, I'm Cheuk, and I love open source projects. I am very enthusiastic about it. I have, so before I joined TerminusDB, I was a data scientist. I'm also interested in AI or this machine learning, interesting stuff. But I'm also interested in open source technologies. So I have a few projects that I participate in. I'm also now working full-time with TerminusDB, which is also an open source project. Also, I've contributed to other projects. Really love that. So I also organize events. Involved in a lot of different conferences, mainly in Python. I'm now the board member of the Euro Python Society. Also, I help out in PyData Global, which is happening next week. And also, I'm organizing another online conference at the end of the year. So, also I used to, during the lockdown, I used to Twitch a lot because, well, what else am I gonna do when I'm at home? So, but I'm doing it less nowadays. I love outdoor as well, so it's kind of difficult to balance sometimes. So that was my introduction. So let's jump into the topic today. So what is a graph and why do I need to put data in the graph format? I'm quite happy with, SQL, like even sometimes Excel spreadsheets. I like, having things that I can see very easily. It's fine, like even in some spreadsheets, you can filter things out, you can find things. So it's okay, it's manageable. So why do we need more? Well, as a data scientist, of course, well, I was a data scientist. So as a past data scientist, I would say that, well, while Excel is good for a lot of small things, like for example, my personal stuff, but if you work in an organization, sometimes it's not good enough. Sometimes, you have lots, high volume of data. It may be coming from another service that you need to hook it up with other applications. Or sometimes you work with different people. It's like, I'll talk about that in a bit as well, like the pain of sending files over and around and then changing it. And then there's another thing sending back over. How could I keep track of all these versions? How can I gonna back up my files? So yeah, it's a bit of a scary thing. So data management is very important. Also data modeling also help a lot in this kind of thing. So yeah, like even though during my data science years, I have spent lots of times just dealing with, varying from CSVs. Well, data scientists love CSVs because you can, it's very flexible. You can like put it in. I'm a Python lister, so I put it in Python. Jupyter Notebook, Pandas, do a lot of things with it. So CSVs recurring theme there. So other things, including sometimes, my side project, that would be like Google spreadsheets. Excel is more used by corporate when I work in a big company that, like my colleagues from another team that's not so technical than me prefer Excel spreadsheet because it's easy. Yeah, but we are talking about why they won't fit, because imagine you have a lot of data coming from different sources. that they're all formatted differently. Or if you work in a big organization, I used to work in a big organization, there are different teams and their data need to be protected in a certain way, that some data are sitting in some more secure database, some are sitting in less secure database, some are just like some data that I need to get from a team that only share among themselves. So the format totally like varies, even though they're all relational database, even though I can use SQL to to get data from all these different database, it's not good. Is a pain. Like you have to get everything together, and then if you can code, of course you can okay, like for example in my case, use pandas, put them together, join them together, and then have something that you can present. Then how am I going to deal with it? I can save it as a local version in CSV in my computer, but what if I want to share with other people? So it's not very, very good. Joins, I hate joining tables. I don't know how many of you resonate, but sometimes easy stuff that can be done, I need to make unnecessarily many joins to join the table together using the key, making aggregate, you have to aggregate it, and then, sometimes counting how many of them are there, or having some statistical calculation like sum or mean, and then join them back to get some results, and then you can have some reasons out of it. So too many, too long, the SQL is too long because of all these joins. Data type confusion, I don't know whether you have experienced that a lot of times, because CSV or other database alike, there may be less in relational database. Some of them now you can kind of have some metadata and know what it is, but a lot of time you still have to manually convert the data into the right data type. So also like in a lot of times in Excel, they just assume a data type for you, and then when you kind of having import out export, then it can have some error there that you can change the data type into something that you don't want to. My personal experience is that I have not even Excel, I retrieved some data from a database, but how they got handled is that so some of the data that was quite new is from an API, so the data the ETL process was done correctly. So for example, some IDs they are treated as string, so the trailing zeros are there, but at some older data there, that the IDs was probably like piped in a different way, that it got handled as an integer, so all the trailing zeros are gone. Funsies, I have to patch all this zero back in, which also make things super confusing. So why a user like have 3 digits of ID, and like some newer users have 5 digits, like what's going on there? So because the trailing zeros were gone, a nightmare. So that's not very nice, and so a lot of times we want to avoid those. Also SQL hearts something everybody knows, injection, because SQL was passed around as a text, so it's very easy for someone to if you just like take someone's input and then put it in, stick it in your SQL query, then it could contain, if you don't know what this thing come from, it could be provided by a user. It could be, someone can put something in to alternate your code. For some extreme cases, you may lost data or, compromise the security, which is not good. So there are a lot of limitations there. It's kind of, a thing in the past, because we have been using relational database for almost half a decade now, so it's quite old. So come to the new world of semantic graphs. So semantic graph, so what are they? They sounds cool, semantic, it sounds very smart. It's like AI. So what it is? So I think that if people ask me, the most easiest way to explain is that imagine a data lake. The data lake, is easier to understand now because it's something that now people have more, exposure of, like, there's a lot of different, like S3, like, Google storage, like all these software, they're data lakes. They are just like, blob of data, you can put it in. So it just store a lot of things. But it's not structured. So imagine that with these data, like you can put anything in, but you can build a structured on top. So basically imagine a lake full with fishes, and then you can basically have this fishing line that kind of link all the fish together so you can easily get them back. So that's exactly what a semantic graph is. All these links are very flexible. You can have data that with strange structures, nested structures, very, very weird structure and data type, you can still link them together, provided that you have a good schema, provide a good definition of data type and all this stuff, which will involve RDFs, which I'll talk about in a second. So, so provided everything works right, you can you can find your data back within this crazy lake, but it's very flexible. It's like a lake. You can put any fish in it; it will fit. As long as it fits, you can put it in. So, also you can store the metadata as well. Not just the fish. You can also fish with different colors, different species. Like you can just look at them. So it's like I said, the data type, it's also there, or even sometimes more than data type. You can even put down comments, some kind of side notes, or even maybe who can access this data, who can get this fish, who can catch this fish. You can even have a control over it. That would be amazing. That would avoid this nightmare of different teams have different access. You can be like, okay, so for example, everybody can go to this lake that store all the data in a company, but only HR team can access some personal information. So kind of things like that. But semantic graphs need to use this RDF schema. So there are semantic triples and RDFs. I talk about this a lot in my workshop, which that I will spend an hour talking about this. So I think I would not go too deep today about RDFs, but basically it's just imagine something almost like an HTML, but it's describing what things are and what their relationship is. And triples basically just means that how two things are related to each other. So two things in a relationship, three things, triple. So yeah, this is the thing how a semantic graph is built, is using the semantic triples. So example time. This is the table, right? And so I would be, quizzing you whether you know what the table is about. So so let's go into your mind and look at it together. So okay, there are names with these are people, right? So there's 7 people, a date of birth, and mother and father. So okay, mother to, or maybe it's been like Mary. So now it makes sense, like, it may be a family tree. But the thing is that in your mind, you have done some amazing joining. So you have to really go from, mother, and then you have to probably use this ID and join this back. So in SQL, you have to literally join it back, right? You have to, use this key and then, join, like, have a left join or something, like put it here, and then you also need to deal with the nulls. Some of them can't handle nulls, so you have to join them, and then you have to, okay, then now I can get like, the mother's name is Mary, okay, something like that. So, and also, what if you have to find John's grandmother? It's like, okay, I know John's mother is Mary, then you have to make another join to find, Patricia is John's maternal grandmother. Not ideal. What if this, I give you this, is just clear. It may be a little bit confusing for the colors. So also there isn't enough contrast in the color, like it's not accessible. Sorry about that. But but you can see that, okay, so maybe the gender color code. So I know that our parents, so which one is your biological mother, which one is your biological father, it's quite clear. So I don't know why this arrow is blue. It's a bit funny. Anyway, so yeah, so you can see that if you want to find the relationship between Patricia and John, you just need to go through this path, and then mother's mother, so it's maternal grandmother, right? So this picture you can, well, first of all, it's a family tree. Well, maybe because we are used to looking at family tree in the graphical format like this, but also because there are information there that is quite easy for you to access. Also, the meta is here, like I said, the color code and also date of birth is just in the object itself. So if you imagine all these people are an object, each one of them are object, and then they have the relationship that links them together. So this is a semantic graph. So we can totally build this graph with RDF with a semantic graph, but RDF is quite scary. So a backstory about TerminusDB. So we just launched our version 10. Yay, amazing. Version 10 that has a big rewrite. Reason being, when we first launched TerminusDB 1, or beta or something like 1, 2, 3, they are using a query language called Waco, which is very similar. The idea is based on RDF, based on triple. But the feedback that we got is that is quite complicated to use. So that's why we decided to improve it a lot for everybody. So we introduced this document interface. It's a big improvement that, we now don't have to write things in triples. We don't have to describe, for something like this, I will probably in triples, I may have to say like, okay, John, you can't just say like, oh, John's mother is Mary. That's already like a very high level stuff. For more low level, you have to say, oh, John is a person first, and then Mary is a person. So you have two persons. Now you can say, oh, John's mother is Mary. So there's 3 things to make this work. So you have to write a lot of triple, which is a bit difficult for someone who hasn't done any, has no exposure of semantic graph or understanding of triples before to do it. So what we think that, okay, actually is quite similar to object-oriented like programming, right? We just have to, so instead of doing the meta of like making sense of John is a person, we have to just build a schema that describe that, okay, we have objects that they are persons, they would have a date of birth, and they would probably have a gender, well, biologically in this sense. And then they would also have a name, and probably maybe their mother and father, like relationship with other people. So you build a person as a type of object, and then you can create person objects. So this is object-oriented way of thinking. So you can think of, okay, so now I can create a person object, John, with date of birth, this one, and with, for example, gender is male. So let's say John's biological gender is male, and then mother is Mary, which is another person object, and then father is John Senior, which is another person object. So you just build all these like these family members as a person, and then you can just link them together. This is much more easy to understand. Also, the schema, like I said, for example, we have person objects, and then you can have relationship like mother and father, which could be optional. Some of them could be missing because you may be, if you see your ancestor, then you don't know who their parents are because there's no documented history. So, but you have a mother and father that is another person. You have a date of birth, which is a date. You have a name, that's the string. So so this is all self-explanatory, the schema. I'll show you in a bit that it's quite easy to see what's going on in the graph instead of triples that you have to kind of think in a way to make sense out of it. Comments are very welcome. You can add comments easily to the object to describe what it is. So sometimes a person, so you may want to explain a little bit, oh, this is a family member in John's family or something like that. You can explain it. So person doesn't mean anybody in this use case. Person means John's family member. Also, because it's always been the case, but document interface doesn't change the fact that we handle queries and data in JSON array format. So it's quite difficult to inject because it's not a plain text. Everything is structured as a JSON. So for someone to inject something is almost impossible, because I would declare the type of the user's input. For example, oh, I create a new person. What's the name of the person? It's a string. So people can't just like, oh, maybe I can inject a little bit funny thing and then put a dictionary in it or JSON in it. It won't work because it's still considered as a string. Even if you put like curly brackets, like how JSON will look like if you open it on an editor, it's still not a JSON. It's still considered as a string. So so you can't inject things. It's impossible. So this is how a schema will look like. So this is what I get from the Python client. This is an example schema. So first of all, the schema itself can have comments to say who are the authors, the description. You can have multiple authors actually, the title, and these are just Python thing. You have to import the object from the library, so we can ignore that for a bit. You just declare class like this. So everything is very object-oriented programming style. You just so subdocuments. Another thing, I won't dive into detail in my workshops, that it will dive into more details. Or if you go to our tutorials, then there will be explanation. So like, for example, country object, it got the name, that's a string, and then also known as would be a list of string that could be maybe some country would be known as other name, like I base in UK, right? So United Kingdom, sometimes people just call it Britain, or like actually like some people call it England, which is not correct, but some people do that. So yeah, so it's so you can also have this. So so all these are very clear. You have the comment. You can even explain a little bit what is that by writing it in a certain format. So this format is called NumPy documentation style, but I won't go into the detail for Pythonista. It may be familiar to you. So yeah, so this is just how you describe the schema. And after that, all the data are objects of these kind of things. You can have relationship, for example, like employees. You can address of expecting an address object, which we have it somewhere above. Yeah. So you can have this object, embedded in other object as well. So it could be a nested structure. That's quite nice. You can even have a circular structure. You see that managed by employees. So it's kind of, oh, it's a bit circular. What if, what if someone made a mistake and then, A managed B and then B managed A? Well, it will still work because it's, linked up by reference. So it won't break the database. It may be troublesome if someone try to get the data back, but and realize there was a manual error, maybe manual input error, but it won't break the whole system. So that, and then so that's the first kind of reason why you have to use the graph database, because of the flexibility, the good thing of you can have a 3D structure of data, everything just make it much easier. So the next advantage would be you can do something like it, revision control. So for coders or developers, or even if you code and if you use Git, then you understand that Git is very good in collaborating, making copies, just to make sure that your work history is saved. So in case of emergency, just roll back. Yeah, it's funny because like at work today we just did some kind of rollback kind of thing, that yeah, so it's very good. So we all know this, right? So data scientists love CSV, but the problem with CSV is that we have this thing that we have some data, we clean it, and then we put it in the model. It doesn't work that well. Maybe I should, do a little bit different, processing the data a little bit different, and then try it again. It doesn't work. Then I have another model, and then I would, need to change my data again, and then, you know, so you have, but you want to save all of these, right? So in case, you know, the final model is not as good as the first one, you may want to go back to the first one. It's a mess. How, like, what should I do? So first of all, so you ask, oh, if I have a CSV, I can still use Git, right? Yeah, but Git are designed for code, but not data. So like, even for example, if you open a CSV file with a text editor that is so difficult to see, for code, it's okay, because the code, like programming language code, are designed that there are certain readability, right? So that's why in Python we have PEP8, so this readability is considered. But something like a CSV is not meant to be read as a plain text. It's meant to be, you know, you put it in some kind of software like Excel, something like that, that you could, you know, you can see it quite nicely formatted, because, you know, if you open the CSV, you see that, you know, some of the field are more long, some is like longer, some of it like shorter, and then, you know, it's difficult to make sense like which one of those are columns. So, but if you open it with a software, then it's easier to see. So, yeah, so maybe Git is not the best tool, even for CSV. What if you have something like Excel or something, even Jupyter Notebook would be a little bit difficult to track with Git. So yeah, so it's not perfect for everything. Also, since we store data in a graph, so if you look at the Git history, it's kind of look like a graph, because you have commit linked to each other. So this commit come after this commit come after this commit, and you can branch it off from this, and then you can, you know, all this stuff actually are a graph. So why don't we just do it with a graph database, right? So dive a little bit into the technical details. So the data store as layers, so it's quite efficient in theory. It's quite efficient, even like you know, even though there are a lot of you know, things that we are improving, but you know, we can achieve for a very good efficiency. So for example, you can see that we have, so all these are layers. So this is how data store. So this is the initial one, and then you can actually have some commit that the red one, for example, are deletion, and the green ones are insertion. So we have a commit. So this is quite fast. I don't know why my computer is very well today, so it's quite fast. Sorry about like it's going so fast and difficult to see. But then, like, you know, we have that commit, and then we just link them together and remember what is being created, what is being deleted, instead of like just storing the change like one by one. So oh, I don't have an illustration here, but we used to have an illustration saying like when you query it, it just like try to find whether that object exists. If you know, if it got deleted, it never, well, it doesn't exist nowadays anyway. If it got created, then we found it. So kind of things like that. So it's, if everything is stored in layers, it's quite easy to see like, or what is deleted, what is created, and then when you query it, it's quite fast. So yeah, so imagine you have a service that's host online. It's just like GitHub, so it's host online. So you can even collaborate between different teams, different people, even outside of your organization. So that is something that we are trying to achieve as well. We have a cloud service, Terminus X, which is exactly like TerminusDB because it's powered by TerminusDB, but it's a cloud service, so you can you know, you can store everything there, collaborate with people, so it's quite nice. Also, you can create data ops, so everything could be, we have clients, we also have API endpoints, so everything could be hooked up with your application. I already have some users come to me saying like, oh, they create a schema using Python, and then their application could be using the JavaScript client to you know, having data in and out and all this stuff. So so because we have the developers in mind, so it's integrated with other mechanics very easily, like, not just web application, maybe like machine learning. If you want to run a Python script to get the data, run your Python script, run your analysis, and then put it back, is good for the job. Also, better data governance. Like I said, again, like this is in the roadmap that we would have, better access control. So you can share data, like you can control who you share the data with. You can share it maybe within your team, you can share all this data, but outside of your team, maybe only limited subset of the data you want to share with them. So yeah, like we have some time left actually. So let's try to time travel into the demonstration. So I think that I can't demonstrate everything because, live coding, usually I would leave it more time because, unexpected things may happen. So let me show you this. So let's see. This is our tutorial. It's on our GitHub repo. I can show you where it is if I have time at the end, but if you go to our TerminusDB GitHub repo and go to the tutorials, it's there. So this one, I already started this project. So if you do log, you see that I have already done a lot of things. So so there's a few things I want to show you. So this is a command line interface that is powered by the Python client. So if you're wondering, oh, how can I do this? It's like, oh, you just download the Python client, get the TerminusDB. You can run it locally with your, get the TerminusDB Docker Hub image. We have another repo of doing it. It's called TerminusDB Bootstrap. So you just follow the instruction there and get it running, and then install a Python client. Or if you really like cloud service, I think TerminusX is still in the beta program. So if you go to our website, you would go to TerminusX sign up. You can sign up as a beta tester, which is for free right now. So you can try all this cool stuff that TerminusX provided. You can just, the Python client also work with TerminusX, so you can also try it out yourself. So, enough of that. So let's have a look at what I have right now. So actually this command line, I can show you a little bit before I start. So there's a few things you can do. You can import and export CSV, which I'm not going to demonstrate now because I want to focus on the time travel. There are also other things I will show in a bit, which is like branching, checkout. So this is really Git-like things. Commit just means that you push the schema. Again, I won't spend too much time today about this. You can delete the whole DB, which is dangerous. You can also make queries using this. So this is for you to inspect, or docs means that you want to inspect what's in the database right now. Status will show the status, what things you're connected to right now. Saying just want to update your schema so you can see what's going on right now. Log, I just show you, is just like Git log. So you see what commit was performed. Reset and rebase. I will see if I can do a little bit of this today as well. So let's try to, okay, so first of all, I would want to see what I have. So TerminusDB, I always type Git because I'm so used to Git. So I have to be really careful that I'm doing the database, TerminusDB, not Git. So TerminusDB, I want to see what branch I'm in. So you see that I'm now in the main branch, and there's another contractors branch, which I'm going to delete in a second. But also you can see status as well. So yeah, it's just that I'm showing I'm connecting locally. Like I said, you can connect to TerminusX, or if you can host, your the Docker image of TerminusDB on your own cloud service, you can do that as well. But that needs more kind of technical setup. So yeah, that's that. So I'm also on branch main, so this also show you the information. So what I'm going to do is to delete the branch contractor. So I just delete it. So I want to start from scratch. So now if I do TerminusDB, I am only in main because I only have main. So clear all this. What I want to do is to create a new branch. We create a contractor branch again and do some performing thing, and you'll see what's going on. So TerminusDB. So now I do a branch contractors. So you see that I have created a contractors branch. So I'm now on the main branch. So what I can do is to do a checkout. So I'm lazy, so I'm just going to change that. So, oh, I spelled it wrong. So yeah, live coding always a thing that can go wrong. So what I'm going to do is branch. Now I'm on contractors branch. So now what you can do is to import CSV, export CSV, do all this stuff. But what I'm going to do now is that also contractors branch is going to branch off from main branch. So if I do a TerminusDB log, so it's the same thing as before, if you can remember what's happened before. So exactly the same. I have a few commits, and the last thing is that I'm adding Ethan. So yeah, we're like, why Ethan? You will know it if you follow the tutorial, but this is the end bit of the tutorial, so it's already at the end. So you see that the last thing we did was adding Ethan. So okay, now I've done it. So what I'm going to do is that I want to add contractors. So I've already written a script about it. I won't go through the script now. If you're interested, go through the tutorial, try it yourself. So Python, I want to run the script that I wrote right before. So add contractors. I'll just run it. And then now, if I do the log again, you see that I have done something with the database, which is kind of like a Git commit that I've add contractors. So I've done it with the Python script. So can I show you the Python script? Maybe let me give it a try. So this is the Python script that I run. Yeah, it's difficult to explain because without this highlighting, it's difficult to see, isn't it? But what I did is just that I have a few more people, employees that I added in the so adding contractors. So that's that. So now I have these contractors branch, and I have add contractors. What if I want to try time travel? I want to go back a step. I don't like it. So what I'm going to do is to do the log again. So so if you are familiar with Git operation, you know that what you want to do is to reset, back to this commit, right? So you want the head to be this commit instead of, so the head is like what we are now. So we are now at here, adding contractors. So we want to go one step back. So we want the head to be here instead. So what I'm going to do is to copy this, and then what I can do is do the TerminusDB reset, and then this. Okay, so so reset, and then the commit ID. So it had hard reset to this commit. So hard reset, for those of you who understand Git, will be like, oh, well, you're really back here and you lost all your progress afterwards. So if you show the log again. Yep, so you have lost all the progress after adding Ethan. So luckily we have a script, so we can do it again if we want to, but it will be different. The commit ID will be different. So yeah. So yeah, you have time travel back. You have another option to soft reset. There's an option to do that, which just lets you temporarily go back to wherever you want. You may want to have a look before you really hard reset. So that's also an option you could do. What you can do also, there's other things like you can rebase. Basically, it's kind of like a merge, but not exactly. So you can use rebase to do something similar to merge, but it's not exactly like merge. If two things are modified different ways, you really need a merge, which we are working on at the moment. So your rebase won't work, but right now you can kind of, do a rebase. Rebase is easier than a merge. So we have implemented rebase, but merge is still work in progress. But we'll get that done very soon. I know that they are working very hard on it. So this part is it is, so we can so yeah, I have shown you the time travel. So we have like slightly more than 5 minutes, I believe. So maybe I will see if there are questions, or actually, let me go to the last slide. So before I move on to take questions and other things, I want to show you that, well, we are on Twitter. You can also, follow us. There are lots of jokes on there, and also the news about what's new. Maybe you see that, oh, merge is now done. You can now do merge and other stuff. Also join the Discord community. We have lots of amazing things there. Ask questions, discuss about how you want it to be, or what you like about us, or what you don't like about us. You can also tell us. The website, and now we have public beta. Like I said, you can sign up for free for Terminus X right now, which is a golden chance for you if you want to try Terminus X, because this is a cloud service. There will be a price, but right now it's free. Everybody can do it for free, or you can just download the open source version TerminusDB to play with locally. Other things I want to show you is our repo. So just go to GitHub, find us TerminusDB, and then there are documentations, and then there are also the Python clients here that you could have a look if you're interested, or the most important thing is tutorials. So the thing I just showed you is at the getting started tutorial here. So there are 6 lessons. What I show you is covering the last lesson. So if you want to follow what's really going on with Ethan and the other people, then play with this, I guess. So I guess that's really all the time that I have before Q&A, I think. So any questions? Go back to the slides for people who want to.
You have about 5 minutes remaining for questions. If there aren't any, feel free to use the remaining time however you like.
Yeah. So if there's no questions, I think let's see what I can maybe show you a little bit more about the tutorial. I haven't really prepared what am I going to do if there's no questions. So okay, let me go back to the tutorial and see what else I can show you. So tutorials, we have by the way, let me show you something very cool. It's a bonus. We have a connection with Singer.io. So what is Singer.io? So Singer.io is an open source ETL tool that actually I can give them a shout out because it's also open source. I love it. So how it works is that it got different tabs and target that you could get the data from the tab. You can connect it to any of these services and TerminusDB plus TerminusDB. We are new, we haven't added in yet, but maybe we can talk to them. Hey, we have a very cool tab that's available. Also, target is like where you can get the data in. So TerminusDB have both, have a tab and a target. So the demonstration and tutorial is here, also in the tutorial repo. You may want to have a look. For example, exporting the data to Google spreadsheet and the GitHub data. You can get this GitHub data into TerminusDB. You just have to set it up right. So the setup could be quite complicated depending on what what data you're using, which tab and target you're using. But once you set it up, it's easy to just update it to do it again and again. Sometimes you may have to run the tab and target every day or every week, so you can update your data from one place to another very easily. So you can build a mix and match data pipeline. So it's quite cool. Also, there are other things. If you want to see how a complex schema could work, you can look at the nuclear power plant. This one is quite complicated things, so that we have done. Also, there are some other simpler ones. So we are still expanding this repository to show you all these different possibilities of using TerminusDB. So, and help you with your ETL process, with how you manage your data to make your life easier. So I'm happy for you to just talk to me about what you like, about what you want to have, or what you actually, if you have tried it, if you totally don't like it, or anything you want to complain, I'm all ears. Just let me know, or go to the community and let us know.